Hey friends, today's sponsor is Datadog, a real-time monitoring platform that unifies metrics, logs, and distributed request traces from your cloud containers and orchestration software. You can track the health and performance of your dynamic containers, your apps, services, with rich visualizations and machine learning-driven alerts. Datadog's new cluster agent streamlines data collection from large container clusters and allows you to auto-scale Kubernetes workloads based on any metric that you're already collecting with Datadog. To start monitoring your container clusters, sign up for a free trial today, and Datadog will send you a free t-shirt. Visit bit.ly.com/DatadogShirt to get started. That's bit.ly.com/DatadogShirt. Hi, this is Scott Hansel, and this is another episode of Hansel Minutes. Today I'm talking with Sabrina Smai. She's a software engineer in the commercial software engineering team at Microsoft and works with partners to solve business problems using machine learning and artificial intelligence. And I met you at a hackathon. And is a hackathon where you got into ML and AI?
That's exactly where I got into artificial intelligence and machine learning. And it was just such a fascinating space to be able to see all these incredible people in one room using these technologies to impact the world. And that's when I was sold.
So you were also a teacher, and you were a teaching assistant, and you taught at your college to kind of give back. So it's kind of natural that you would be doing the same thing at hackathons. And actually, I met you at a hackathon, learned about AI, and I wanted to bring you on the show and talk about it.
No, I'm super excited to be here. So hopefully other people can learn about how, I got started in machine learning. And hopefully as soon as they turn off this podcast, they want to pull up their ID and get hacking with machine learning. So
yeah, it feels like there's so many buzzwords, as with anything. You have to go and learn all the different acronyms and different words and stuff. And I'm sure that people have had a lot of failed attempts at getting started. I know that I've tried and then just gave up and put it down for a while.
Yeah. No, that seems to be a reoccurring sort of situation with a lot of people just attempting to learn something that's super broad and vast. So, no, completely understand. Yeah.
Did you have any trouble the first time that you installed TensorFlow?
Oh, the first time that I downloaded TensorFlow was actually really funny because I thought that I was the only one. I remember I was looking at all these demo videos of these neural networks learning how to play Super Mario and StarCraft, Dota, and League of Legends, and I even saw a 17-year-old that built a rap song builder for Kanye West using LSTM, and I'm like, okay, I need to learn this ML stuff. It's way too cool. And I remember that night I tried installing TensorFlow, and this is a typical story that people that attempt machine learning for the first time, and then they go in, copy and paste code from tutorials, and for me, I was copying and pasting a tutorial that was from the MNIST dataset, which is for handwritten digits. And I remember I had no idea what was going on in the script, but I was getting great results from that neural network. It was fantastic, but every single modification that I would make would throw me an error because I was new to Python syntax. I had no idea how to write a neural network. And I was like, okay, let me take a step back, and did what any seasoned newbie would do and binged it or Googled it. And what I typed in was how to write a neural network. And of course, to my surprise, not really. But there was all this mumbo jumbo math lingo and symbols that literally looked like alien language. We were just talking about aliens, you and I, before this podcast. So everything looked like alien languages. And there was terminology and sentences like, use the sigmoid activation function to transpose the product of derivative, back propagation through time, blah, blah, blah. That did not make sense. But that's the stuff that you usually hear. And I completely felt defeated. But I didn't want to give up. So that just seems to be a typical story that a lot of people have. And then you get super excited when you hear about courses like Coursera with Andrew Ng. Get really excited, and then maybe halfway through the course, it still sounds like Zarlorg, alien language.
Let me parse some of that, though, because there was a lot of information there. And sometimes what happens when we're learning these things, and I think you just fell into the same trap, is we throw out words or acronyms we don't understand. So two that I didn't follow in your sentence just there. First one was LSTM. you said someone was making music, long short-term memory units in recurrent neural networks, and then you said MNIST. What are those things?
Yeah, so LSTM, exactly right. Long short-term memory, which is a recurring neural network architecture. And in this specific case, it was learned to learn the style of Kanye West to sort of generate music. So this is mainly used in cases like that. And the MNIST data set is a data set of just handwritten digits that it's kind of the canonical example data set where a lot of people use to learn, especially learn neural networks. And it's just a data set of handwritten digits, and you're trying to train a neural network to try to read what they are. So
it seems like there's a lot of these data sets. There's pictures ones, there's cats, there's handwriting. This is a really common thing. And some of these are like 20, 30 years old. They're just like files, and somehow they became the hello world of machine learning. Right.
Yeah, especially the cat and dog for deep learning. Is it a cat or is it a dog? The MNIST data set is another good one. The Iris data set is another canonical example that a lot of people use for classification problems. So yeah, those are definitely the famous ones. So
are these ones that everyone learns in school? And if we are now out of school and listening to a podcast, are these the hello worlds that we're going to go out and learn about and try when we do our own self-directed learning?
It seems to be the examples that you see online over and over again, like on Kaggle. You see it a lot in the tutorials. So they're sort of everywhere, and a lot of people talk about them. They're examples that you just constantly see online. So yeah, these are great examples for you to get started on. Like I think for binary classification, when I was helping to teach, I think the Iris data set is the one that I was really focusing on. The MNIST data set is the one that I attempted to learn because that was the first thing that popped up when I typed in how to write a neural network. But again, there was all these crazy vocabulary that I had to learn. That's why I decided to shift my learning approach to try to speak alien instead. So I was typing up these machine learning terminologies instead of trying to follow these tutorials. It wasn't really helping me.
So you just said Kaggle, Kaggle. It looks like it's like, the CSS workshop or JS Fiddle, or like it's one of those websites where you go online and you mess around in a sandbox. So this is the JS Fiddle of machine learning?
I think that's a good way to put it, actually. Yeah, so a lot of people ask me, like, hey, what are your tips on trying to learn machine learning? And one of the tips that I tell people is Kaggle competitions are a really good way to not only make money, but to actually get your hands dirty and try to learn how other people solved solutions. But also, there's a bunch of data sets, like the Iris data set that's actually on Kaggle. There's all these different competitions that you can get a part of and learn how to apply these machine learning techniques through practice.
Well, hang on. You said make money. Now I'm over here at kaggle.com/competitions. And there is, like, for example, at the time of this recording, can you identify a humpback whale by its tail? There's 1,300 teams that are all competing for $25,000. When did this happen? They're giving money away? Is this like the Netflix challenge now, and they're going to give us cash for solving problems?
That's exactly right. I mean, a lot of these companies are trying to find unique solutions for a lot of their problems, and they're actually going into Kaggle and just proposing a lot of money for a bunch of data scientists or machine learning engineers or even developers that are just wanting to use their creativity to try to solve a challenge. And people get jobs from Kaggle. People get money. And it's funny. I've never won money from Kaggle, but there's a chance that you might.
I'm literally, I can think about this. I know nothing about machine learning. I know squat. And I'm sitting here right now, like, thinking I could maybe win this money. Like, how hard could it be, right? It's like a whale tail. I want to look at the tail, because basically what they're doing is they got all these photos of whales breaching, and then their tail goes down, and then they have 25,000 images. in the Happy Whale database. Happy Whale, one word. And basically they want you to give back a CSV file, a comma separated value file with the JPEG picture name and the whale you think it is. Like, that's awesome. And you could win money.
Yeah, no, and even for people that are just getting started, there's a lot of data sets that are actually, because a lot of people tell you that it's the data cleaning side of things is the most difficult part because that's 80% of your time is in that stage. And there's a lot of data sets that actually have been cleaned for you on Kaggle, so you can just kind of just jumpstart into. I mean, of course, you need to do some analysis on the data, but then the feature engineering and some of the data manipulation aspect has been done for you, so you can just apply your learning on algorithms and stuff like that directly on Kaggle. So it's definitely
cool.
approachable. So
they don't seem to tell us that. You just said that most of machine learning is cleaning up the data. Really, it's a garbage in, garbage out situation.
Yeah, that's correct. But some I've seen a couple of competitions on Kaggle that already have it's meant for beginners, and the data set has been cleaned, slightly cleaned. I mean, it's still a little bit dirty, but it just allows you to just kind of jumpstart a little bit and make it easier for beginners. So
that's deeply cool. Okay, so you said that you started doing your self-direction learning as you were, doing this in college, and then now out of college and working as a software engineer. What did you change to make your first failure turn into a successful learning approach as you were learning to speak ML?
Yeah, so that's an interesting question because I just wish I discovered this beforehand. And again, there's no solution for learning. Like, I can't tell you what the solution is for getting started with ML or learning, because we're all unique individuals and we all have unique learning requirements. So I can speak about what worked for me. And for me, I started to realize that, when I was taking the Andrew Ng courses and when I was, learning through these courses and researching, I was realizing that there was one thing that I was getting stumped about, and it was the machine learning vocabulary was throwing me off. So that's what I decided to do. I decided to change my learning focus to speak alien instead. So for instance, if there was terms that were reoccurring over and over again, like activation function or backpropagation, or even that, weird looking E symbol that you find in all these equations, like what is it and how do you calculate it? So I decided to say, hey, let me research that. And it turns out that weird looking E symbol is the Greek symbol for sigma, which is a mathematical way for you to indicate the summation of an array or matrix. So I did this for months and months over and over again, and things started to make sense. So whenever I had something that was unclear, like an activation function, I would isolate it and sort of ask a bunch of questions and then research them. So when I went back to these Andrew Ng courses on Coursera and these courses that I thought were just really, really great for the first half and then started speaking alien, I flew through those afterwards. So the Andrew Ng course is fantastic. Just, I wouldn't recommend it for someone that's just really starting off.
Mm-hmm. And for context, Andrew Ng, that last name is spelled NG. He founded and led Google Brain, and he worked at Baidu, and he's a professor at Stanford. And his courses at Coursera, and I'm going to have links for everything that Sabrina has mentioned is going to have links in the show notes. Those are kind of considered the gold standard for Machine Learning 101. But as you say, it requires a certain amount of vocabulary, where that vocabulary might be a little bit of math or a little bit of this, or a little bit of that. And without it, it's going to feel really difficult to follow.
That's exactly right. And there's many things to consider in terms of like learning, getting started with machine learning. Like maybe some questions that you should ask yourself is like, hey, are you a top-down or a bottom-up learner? And what I mean by that is, for me at least, I'm more of a top-down learner. And what that means is that I like to understand the high-level theory side of things, just sort of speed through everything that has to do with machine learning on a very, very high level, and then sort of take it a notch down, a notch deeper and deeper and deeper, and then look under the hood and really get into the nitty-gritty math portion of it after I know the theory. But some people are not like that. Some people need to know all the math, like the low-level math first, and then start taking it a level up, and then sort of start mapping these theories to these mathematical calculations afterwards. So these are the things that you need to consider, because maybe if you're a bottom-up learner, then the Android course right off the bat would be helpful. But if you're not, then maybe taking a high-level understanding of machine learning through Udemy or Udacity or something like that, or the MPP course that Microsoft offers, is a good idea. And then sort of get your hands dirty with the the low-level math afterwards through taking the Andrew course in Coursera.
And the MPP is a Microsoft professional program course as well. And again, we'll have links to all of these great resources that we're going through in the show notes. Interesting. Okay. So it seems like really understanding how you absorb information was a way for you to make sure that you were going to be successful absorbing this totally foreign information, because I assume that in your undergraduate, they didn't exactly teach this stuff. They taught programming, not machine learning.
That's exactly right. And it's great because, I mean, in computer science, it's kind of like, oh, as long as you sort of produce this set of outcomes, you get an A. You don't really learn about what type of learning style that you absorb when it comes to the theory and stuff like that. And that's something that I just sort of learned when I was getting started with machine learning. So yeah, and this really helped speed up my learning process.
Hey folks, you're a very good developer, probably. Regardless, you do write bugs. That's unavoidable. What is avoidable is wasting time trying to track down the cause of those bugs. Sentry.io provides full-stack error tracking that lets you monitor and fix problems in real time. You can see the severity and the scope of the error, get immediate access to the stack trace, connect the problem to the commit that caused it, and fix it without delay. Sentry, it's a name so common that they have to include the top-level domain in their advertising to make sure you remember it. Sentry.io. That's Sentry.io. Open source, full stack, web apps, native apps, mobile games, smart oven mitts. If you can program it, they can make it far easier to fix any errors you encounter with it. Your code may be broken. Let's fix it together. Visit Sentry.io. So there's so many different choices out there, but the ones that keep coming up over and over are Python as the language and TensorFlow as the framework. Is TensorFlow kind of the VHS of machine learning? Like, did it win, or are there lots and lots of frameworks to learn?
Well, there's plenty of frameworks. I mean, just depending on if you're talking about deep learning or just traditional machine learning, but there's a lot of sort of really popular frameworks out there. TensorFlow. Things like TensorFlow, Keras, scikit-learn. And the way that I like to think about them is you don't have to build like neural networks from scratch, for instance. And an analogy that I like to use is it's like having the option of building a computer from scratch or buying a pre-built computer. And things like TensorFlow, Keras, and scikit-learn are kind of like the pre-built computer analogy, where you can just basically watch tutorials and jump right into using them without really worrying about things like derivatives or matrix multiplications or activation functions. It sort of takes away all the heavy lifting for you. But of course, there's trade-offs.
Right. Well, like we are sometimes as computer scientists sold this idea that like the only true Jedi builds his own lightsaber, but at the same time, there's a pretty nice over-the-counter lightsabers you can pick up for nothing. So, do I really want to go out there and write my own, open source neural network library when there's so many other ones that I can use instead? Yeah,
no, that's exactly right. But of course, there's trade-offs to that. Even though they're pre-built, you can get started on them right away, and it's really great for abstracting you from all this lingo that I was just mentioning to you. It's really good for like proof of concepts and stuff like that. But of course, there's trade-offs. Like if something inside your code breaks, that's very on the low level side of things, it might be really hard for you to figure out what it is and what the problems are, and you have kind of less control. It's completely up to what sort of scenario that you're dealing with.
I've noticed also that these are not all necessarily peers, right? So like you might hear someone say Keras and TensorFlow in the same sentence, and you would think that they are two things that compete, but doesn't one sit on top of the other, and then there's a stack? Yeah,
that's exactly right. And when it comes to Keras, and for those of you that don't know, Keras is a high-level neural network library, and it's written in Python, and it acts as a wrapper to TensorFlow. So it sits on top of TensorFlow or CNTK or no more Theano, but yeah. So yeah, you're exactly right. So they're not like interchangeable, but you can still use TensorFlow if you'd like, or if you want to have an easier sort of. It's kind of like using Keras is kind of like building blocks where it's really good for proof of concepts and experimentations, but that's before launching into a full scale like build process or process, however you would like to. The American or the Canadian way of saying it, I don't know.
Did your Canadianness
yes,
just
it totally
sneak out
did,
there?
And people keep calling me out on it. process.
No, don't let them. If you want to say color with a U in
favorite with a U.
It's okay. You should just say that. You should say it like that. You should literally say, "Hello, that's a very nice shirt. I like the color with a U." Just say it with you.
I'm gonna start doing that and make it cool.
Fine.
Make it cool in America.
Oh yeah, you'll make it cool. Everyone will start doing it, and then you don't have to be sorry.
Oh, I like what you did there, Scott. You got me. I'm sorry that you had to say that. All right.
Oh, that's okay. So then there's different frameworks. You can use Python. You can use a lot of these frameworks are written in Python. They have APIs that present themselves in Python. But to get a little bit back on the math, so I know which one of these to pick, what do I need to know? Do I need to go to Khan Academy and maybe I don't know, get a little better and brush up on my math prerequisites?
That's a really good question, because that's a question that I often get asked is, oh my God, math really scares me. And where do I get started? And the math part scares people off. But in terms of what you need to know for math, I sort of have this like pie chart that I keep referring people to. And this was created by a bunch of data scientists, like Siraj Raval, who is really big on YouTube, and all these articles. But anyways, when it comes to machine learning, I would say 35% of the prerequisites for machine learning it's got to be the majority in linear algebra. And then maybe a quarter would be in probability and statistics, maybe 15% in calculus, 15% in algorithms and complexity, and maybe 10% in data preprocessing. And you also mentioned Khan Academy, and I want to give them a huge shout out because they are super awesome. They taught me like most of the math tools that you need to know on writing your own machine learning algorithms. But there's only one downside to the Khan Academy, and that's the fact that you have to build your own curriculum. So that's why I really love the MPP course, which is the Microsoft professional program. They do have a course for the essentials for math that you need, that's important for machine learning. And so most of the time when you're writing your own machine learning algorithm, you'll be given like formulas and pseudocode most of the time. So you having a better understanding of pseudocode and how to calculate them and the various interchangeable indices is very important. And what I mean by that is, like derivatives, you can write them in like two different ways. You can write them like f prime of x equals x squared, but then you can also write it like d times y over x times d. Like they're both calculated the exact same way, but it can be really confusing if you don't know that. So just understanding the various interchangeable indices and how to calculate pseudocode is all really important basics for machine learning success. And that's the stuff that I used. So,
yeah, like we both, for full disclosure, we both work for Microsoft, although we work in totally different groups. But that's actually a very good course, the MPP for artificial intelligence, and there'll be links because it's actually a track of 10 other courses with like 12 hours per course, and you get skills. So it covers ethics and essential mathematics for artificial intelligence is its own individual course on EDX. Some of them are free for studying. They're free for studying, but you can also get a certificate. So if you're kind of getting started and you want to put more stuff on your resume, certainly doing them for free for self-study is great, but also getting a certificate that indicates that you actually did it is pretty sweet. And particularly that essential math for machine learning is a pretty great course. And there's so many things online for self-study, but I think your point about finding one with a track that guides you is so helpful.
You're definitely right. And ethics is another big one. I mean, you mentioned something that, the industry keeps talking about, and they talk to you about GDPR. That's really essential, like legal implications of using particular data. It's stuff that you need to keep in the back of your mind while you're learning machine learning. Will help make the industry a lot better in the future. So
yeah, that's a great point. It's not something to gloss over at all, because there are applied data methods when one is doing ethical work or legal work in analytics, and you want to be able to apply those frameworks. And it may not sound like super glamorous, but it's deeply important. Otherwise, you could inadvertently be unethical in the way that you go and look at data.
True. And there's so many stories of unethical examples online for machine learning. And HP is one of them. HP had actually, one of my colleagues showed me this video of there was an HP camera that was sort of following that sort of follows you based on your face. So if they see your face, the camera will start moving and following you. It seems cool. It's incredible. And this was a few years back, but this is just an example of ethics. When a white lady would walk, by, I mean, the camera works. It seems to be following along perfectly. But then if someone with darker skin tones would walk in front of the camera, it was not sensing it at all. So that's just a terrible example of a product that has been shipped out, and ethics, and there's so many conversations that happened around that, and it's really important topic. Yeah.
Well, and the other one I think is really important is anonymization of data, like looking at a data set and being able to say, do people move in a certain way, or do we need to build a road here because people are moving into this location is super useful information. But it can become very creepy if the data is not anonymized, and then I can go and say, Sabrina is here on Tuesdays getting a sandwich, and that becomes very problematic very quickly.
Oh yeah, definitely. And your example really gave me shivers.
Well, I keep thinking of the Tom Cruise movie, Minority Report, when he's walking in the mall, and it's like we're getting that experience now. It's just we're not walking in the mall, where you get like pop-up ads, and it's like, hey, it looks like you need to shave, buy this. And that happens now when you look at something on Amazon, and then suddenly the entire internet wants to sell you that thing that you looked at once.
The thing that you looked at once and it follows you forever. Yeah, no, that is really, really creepy.
or the show I watched on Netflix 2 years ago that they're still trying to get me to watch. It's like, I just browsed it one time. I don't want to watch that show.
Or if you buy a refrigerator, for instance, on Amazon, like a week ago, and then the next week they're like, but would you like to buy another one? And it's like, no, your algorithm is just not... like this recommender system is not really, it's not great. Let's just say that. But yeah, you're right. Mm-hmm. There's so many examples of just silly things like that.
So if I go off and I learn these things, I do a little bit of work. This is something that I do where I build up my math. I build up my understanding of these frameworks. I take some of these great online courses. What's a first project that you would recommend people start with?
I would say the first project could be starting off with a simple feed-forward neural network that helps you predict what color of a background on a page is. And it's just a very simple project that allows you to learn the basics of machine learning. And the reason why it's important to get started right away on a project, and trust me when I say this, because you trying to write your own neural network from the very beginning instead of just learning about the theory and stuff like that, takes your learning to a whole new level, because as soon as you get started with a project, you're getting your hands dirty, you will get stuck inevitably. And you officially have your first question to look up, and then you keep that process going. So I would say that's one example of one project that you can get started on right away. The MNIST dataset neural network project, there's tutorials on that, but I would say just try to build the feed-forward neural network that predicts color background.
When you say predicts, on like a page or a...
Yeah, so it would take in a page, and then you build a neural network, a very simple neural network that just has two inputs, like black and white, and it would predict what color is the background of a page. And I would discourage you using, because there's no tutorials really for that. But if you build it from scratch, you're forced to research and continue on that curiosity and search things up. You'll really understand the basis of building a neural network.
Forgive my ignorance, but this might be an example of a word that I'm not understanding. You're saying predicts. Is that the ML way of looking at that? Like, it's not really a prediction, right? It's either this color or it's that color. Is it a guess or is it a prediction?
Well, that's a good question. It's just concluding, creating inferences. So maybe my terminology was not like, I guess, machine learning politically correct, but creating inferences. So like concluding or deducing using reasoning through the machine learning.
Okay. I definitely feel like working with a data set that you care about really is helpful. Like, I always use the example of diabetes because I have a personally huge data set of my blood sugar every 5 minutes for the last 10 years, right? In a big giant Mongo database. If you have a database of your kids' sports team or your church's meetings or whatever, you could go and predict stuff like when we're more likely to have meetings or when the most people show up for a meeting, or is my blood sugar lousy on Thanksgiving Day? There's so many questions you can ask. Wouldn't you agree that if it's about something you care about, you'll be more likely to stick with it?
Yeah, no, Scott, I completely agree. I mean, you're right. There's so much data that you're accumulating throughout your days, weeks, and months that you can use to create inferences and make your life easier. And one data set that I actually used for machine learning was actually my fridge data. Weirdly enough, I decided to put a camera in my refrigerator because I guess when I was in college, yeah, no.
You're such a nerd.
Ouch, Scott, that hurts. No.
No, that is amazing. Like, people know that I'm like the Raspberry Pi geek, but you put a camera in your fridge. That's amazing. So please continue. Like, I mean that in the kindest and the most complimentary way.
I appreciate it. Thank you. But it gets even sillier. So I guess back in college, or what we call university in Canada, I realized that I was wasting a lot of food because I guess I was going out to eat, but then, as soon as I decide to stay in, all the food in my fridge decided to rot, because that's not the first thing I think about is like cleaning out my fridge. But I realized that was a problem for me. So what I decided to do is I had at the time, I don't know if they still have it, but it's something called a Android Things. And Android came out with like a Raspberry Pi with like sensors and a camera all in one kit. So I decided to put a camera in my refrigerator, and then every single time the sensor would detect light, meaning that I have opened up my fridge, it would take photos of what's inside my fridge. And then actually using our cognitive services toolkit, which is a suite of incredible APIs that was built by Microsoft researchers for machine learning and computer vision and whatnot. It would basically analyze whether my food was rotting or not. And then I would receive notifications to say, hey, like, your tomatoes are super rotten, so you should probably throw those out. But then I created a middle stage where it's like, it's about to rot, so you should probably use it. And then using machine learning and like scraping the internet, there was, like, for example, if I had tomatoes that were about to rot, and let's say like milk or something that's about to, that was really hard, because the milk part was really hard. But I'll give it another example of like bananas or something. And then it would use the internet to find recipes that included tomatoes and like bananas, God, which is kind of random. But and then it would suggest like, here's a recommendation of like a recipe that you can use with tomatoes and bananas, which that would be a really odd combination of things. But that's just an example of, hey, I had a problem, I had available data that I can use, and I saved a lot of money.
That is freaking amazing. That is awesome. Okay, you have now. I was really excited when I put my Raspberry Pi on my garage door and had it text me when I left the garage door open.
Useful though.
No, that's not nearly as cool as suggesting recipes when you detect rotten bananas with a camera in the back of your fridge. That's awesome. Fantastic. Well, this is just a great example of the kind of cool stuff you can do with machine learning that you can't just do, with a for loop in C#. That's why you've got to, as a programmer, bring machine learning into your toolkit.
And there's ML.NET, so even with C#, you could still do machine learning.
Fantastic. Well, thanks so much for chatting with me today.
Well, thanks so much for having me. I'm really excited that I got to be on your show. So,
fantastic. Cool. So we've been talking with Sabrina Smai, and this has been another episode of Hansel Minutes. We'll see you again next week.